For the next task, write a function that adds all numbers or even numbers between L and R. We will develop more than one solution. So by now you should know, okay, write a function with step. But to develop a solution, we do it step by step, right, from inside out. So what do I have are numbers L and R. So I can always say, hey, for I in range between L and R, give me the numbers, right? Okay, L and R are not defined. I can change this. And again, the in. Okay, so 2, 3, 4. First thing I observed, 5 is not there, right? Well, let's add the end of my interval and close the interval. Now I need to add them. So my sum should start at 0 because 0 is the neutral element of addition. So my sum plus the value of I, and I will store this in my sum again to update the value. So my sum grows as I go over the loop, and at the end I give the value of my sum. Okay, 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 4 is 40. Why is this always coming? Okay. 10 plus 4 is 14. Very good. So everything in one function. Give my even sum L and R. And work with the code indentation and remember to return your result. So let's test it. My even sum to 5. Wait a moment. That sums up more than just the even numbers, right? Even numbers here just 4. 4 plus 0 is 4 and not 12. So what I need to do is I need to add this conditional statement, if case, that if I is dividable by 2, then add to the sum. But again, wait a moment. 4 modulo 2 is 0, because 4 is divisible by 2. But the Boolean type of 0 is false. And when I have a false statement in an if condition, the if condition would not be executed. So one way around is I have to skip if and put everything into else. Or to work with the opposite of false, which is not false, it's true. Well, not true, obviously it's false. I like to put brackets under my conditions. Okay, works. And what else? So let's say 6, yes, 2, yes, works. How about, so the sum between 2 and 6 should be the same as 6 and 2, right? So I change. Oh, doesn't work. Okay, need to fix. So there are several fixes. We could, for example, say if Now, careful. L is smaller than R, or smaller equal R, then my step equals 1, else full step equals -1, and we add a step direction here, and that works. Um, right. We could also swap values of um, L and R, so we could say A and B, some other variables. If A, if L smaller equal R, L is R, A is L, B is R, and if not, A equals R, B equals R, so we go the opposite, and then here we change from A to B plus 1. Test. And 216. Okay, let's change this back. Not too much. Try again. 12, 6. So what we need to do in this case, we need to adapt this boundary here. Cannot be always +1. Actually, must be plus step. There we go. Right? Because if we go from 6 to 2 plus 1, we actually decrease the interval. So we need to make sure that the boundaries are properly met. Okay, let's see. Okay. Okay. There's more. Right? We can use sum, list, and a list comprehension. Or let's do it easy. When we just have range and we just have range. We can make this into a list, and we can sum the list. That would be a very, very compact statement. But we need to adapt that, hey, actually, we want to have only the even numbers. So depending on the value of L at the start, my numbers can be, the first number can be odd or even. Let's see what we have. We will have an even number because we are now skipping every other number. Right? L here is 2, right? Then we say the next one is 4. 4 plus 2 is 6, and that is where we end because R is 5. Right? Bracket. So remember that this is the step size. Good. Right. So L R is what? 5. Yes. So as before, we would have a plus 1 over here. If, however, L equals 1, and that doesn't work anymore because suddenly we start with an odd number. So we need to incorporate a condition that actually allows us to catch, right, to have an odd or even number, right? So, um, L modulo 2 is what? 1. 1 in Boolean is true, right? But if that is the case, right? So if this one is true, um, then the value that we have, right, is actually an even number. So we need to L plus 1 else L and put this in an inline if, right? L is 1, our interval starts at 1, right? So this 1 modulo 2 is 1, so that is true. If it's true, the first expression in the inline if is being evaluated, right? But we want to skip L equal 1, so we want to go to the next one. So a start would be 2. If not, well, we just take L. There we go. Okay, so if that is the case, right, we can now say that defines our start. We go to the n plus 1, step size is 2, and put all of this in the range function. There we go. So no matter what I put as a start for L, I have an even number, right? Then I make this into a list, sum up the values, and I can put all of this now in one function definition manner, even sum. Yeah, and return this very compact expression. However, we still need to see, right? If L is small or equal, then step equals 2, else step equals -2. Step in. Let's try even comma on 4 to 6. What is it? 2, 4, 6, 12. That's like my even sum 2. Okay. And 6 to 10. Right here again. So it's the same argument as before. As when you start with the opposite direction, the start must be shifted. Right. So how do we do this? We can actually actually the start, the end here, the smaller number. So I need to do it with -2. So how do you incorporate this now? This is our actually here, right? Yes, here's the end. r plus 1. So if step is negative, we don't want to have plus 1. So what we can do is take this, put this here, and this over here, adapt like that. Like that. Minus 2, minus 1. Right? To include 2 and not m before here. Okay, that's about it.